Hi everyone, this video is about the Azul project for AI planning for autonomy, presented by Group 36. In this video, we'll introduce the project analysis, our design decisions, the possible improvements, along with our references. The objective of each agent in Azul is obtaining a higher score than its opponent. The game state is observable, where each agent's actions are visible to each other. The agent might come across lots of random opening game states, which means it must have the ability to generalize the problem. More importantly, the agent must make a move within a second, or it will receive a penalty. We tried 3 methods in total: breadth-first search, greedy-first search, and minimax search. The performance of different algorithms is shown in the table. Next, we'll introduce 3 strategies respectively. The first algorithm is breadth-first search. We chose this because of its adaptive and informationless feature, which is ideal for generalization. The biggest advantage of this technique is its high execution efficiency. However, the biggest challenge in BFS is time limitation. In order to ensure that BFS will not time out, we only select those perfect moves that fill a whole pattern line without placing any tiles on the floor line. To simplify the problem, we ignore the opponent's move by assuming we can continuously grab the tiles. Here is the game replay between a naive player and the BFS player. As you can see, the BFS player always chooses the move which can perfectly fill the pattern line. We also implemented the greedy first search algorithm. Different from BFS, it considers the benefits brought by the available moves from the current game state by using a heuristic coming from the score round function. The basic idea of this algorithm is to select the move that leads to the highest score in the next game states. Also, it will attempt to limit the opponent's move. Similar to BFS, we also found it hard to act within the time limit. Using the predefined functions, execute move and score round, we made a heuristic to maximize the player's points gained in the next round. Also, we try to find a move that makes the player lead the opponent the most, while resulting in the minimum average score that the opponent can gain in the next turn. As you can see in the game replay, the greedy agent attempts to collect the complete set. Meanwhile, it also prevents the opponent from obtaining the desired bricks. The third technique we implemented is the minimax algorithm, which we think fits perfectly into Azul. Using minimax, the agent attempts to simulate as many future game states as possible. During the simulation, the agent and the opponent take turns to attempt to limit each other and maximize their gains, so that our agents always expects the worst case during the game. The challenge of using the original minimax algorithm is that it still exceeds the time limit after alpha-beta pruning. To overcome this challenge, we use the filtering technique in greedy first search to retain the moves with a good expectation. This means we are always expecting good moves from the opponent that leads us to the worst cases, which becomes one of the strengths since we never overestimate our benefit from any state. We try different variants of this algorithm. Among numerous experiments we've taken, it is proven that a minimax algorithm with dynamic search depth and consider the bonus points at the end, along with an additional 0.9 second timer, achieved the best result. That is also the agent we used in the tournament. The associated weakness is that it does not come up with the theoretically best solution, since the search tree is not complete. This is the replay where Minimax defeats the staff top team. As can be seen, Minimax attempts to find the move with the maximum gain while constraining the opponent. For future improvements on Minimax, we plan to fuse in more rule-based strategies to further limit the opponent's performance. We are also quite interested in deep Q learning with neural network to better fit in the project's sophisticated features. The 5 seconds at the beginning of each round will be a powerful tool in this case. Thank you for watching. And here are our references.